All right, Mr. G Math coming in live for 7202. Lesson on implicit differentiation. We are now in the afternoon. It is 12:40. That's all it is, right? 12:40. Nothing. On June 29th. Here's our last lesson for today. Implicit differentiation. So, first, if I just asked you as an English person like you are, English major, AP English, the word implicit, do you know what that word means by itself? Even not connected to math. Kind of hidden, okay, if something's implicit. If I say, does that mean you do it directly or non-directly? So, what would the word be for direct? So, if you're explicit means you are direct, implicit means you are not direct. So, all derivatives you have done to this point have been explicit equations. That means directly, y is on one side and everything else is on the other. Explicit. What does y equal? It's there, right? It's direct. Y equals this. For example, y equals x squared. Y equals x over that. Y equals and so on. All of that explicitly expresses y in terms of x. In this lesson, you'll be working with implicit. What do implicit equations look like? The relationship between x and y is only implied. It's not direct. X squared plus y squared equals 1. What makes that more of implicit is that y is not by itself, right? How about x times y equals 1, or x times y plus y squared equals 3? All of these are examples of implicit equations. And most of the time, implicit means they are not functions. Not always, but not functions. So can you take the derivative if it's not a function? That's where we apply implicit. So it is possible to differentiate implicit. So there are some rules to follow. So look in the box. So rule number 1. Differentiate both sides with respect to x. Remember the y prime hook-on factor for any term involving y. Collect all y primes, terms on one side of the equation, factor out the y prime, and then divide. So we're going to practice knowing how to differentiate implicitly. Sometimes you don't need to. Number 1, is that implicit or explicit? Good. So just do it the way we're used to. What does y prime equal? 1. 2, implicit or explicit? So take the derivative. And what does it equal? 2x. 3, implicit or explicit? Take the derivative. What rule do we have to use? 1 and 2, we use the power rule. 3, chain. What's the chain rule? No, the chain rule. So the power with a hook. So 2 times 1 in front is 2. 2x minus 1, the 2 becomes 1. And then the hook, what's the derivative of the base? 2. And we don't need the 1 there, but it's there. Number 4, implicit or explicit? Explicit. How do you take the derivative of that? This should be y prime. Y prime. 2, this again is the chain rule. So the exponent 2 out front, right, times f at x. That 2 becomes a 1. I don't need the 1 there. Times the derivative of what's inside, which is f prime at x. The derivative of the outside times the derivative of the inside. Number 5. Implicit, not explicit. How do I take the derivative of that? Well, what's the derivative of x? 1. What's the derivative of y squared? And that's the crux, right? We need to figure this out. What's the rule for y squared? If it was an x, what would you do? Power rule. It would just be 2 what? Y. Right? But it's not an x, right? It's a y. But that's the rule, correct? What we need to include, though, is there's a hook of y prime. It is like the chain rule. So the derivative of the outside is 2y. What's the derivative of y? Is y prime. So it's the chain rule, but with y. And the hook is just y prime. How would I get y prime by itself? What's the inverse of multiplying? So you would divide by 2y. What does y prime equal? is 2y. When you derive this implicitly, most of the time you're going to have y in your answer. And it's okay that y is in your answer. And you might have x and y in your answer. And that's okay that you have two variables in your answer. All right, let's look at number 1. That was the warm-up. Here's the real deal. You're ready for this. Can you take the derivative of this? Do you recognize that it is not an explicit equation? It's implicit. What's the derivative of x squared? Beautiful. What's the derivative involving y? Do the same rule you would for x. If it was x, you would write down what? Negative 6y squared. But because it's y, we have to include the hook, y prime. That's the difference between x and y in this case. When you take the derivative with y, you have to include y prime, like the chain rule. Keep going. What's the derivative of 3x? Just 3. And the derivative of 6 is 0. So you only have to be careful with y. And what's the hook you connect with y is y prime. That's it. So now, any term that doesn't have a y prime in it needs to go on the other side of the equation. So the term with y prime in it is negative 6 y squared y prime. And then how do I transition this? So we're going to subtract 2x and what else? And subtract. So the inverse of adding 2x, we're going to subtract 2x. The inverse of adding 3, we're going to subtract 3. How do I get y prime by itself? Divide by what? That's it. And notice we now have our answer, and it's okay that the answer has x and y in it. It's going to have both when you do it implicitly. And that's it. Okay, number 2. Number 2 asks, find the slope of the lines tangent and normal to this graph. So to find the slopes that are tangent and normal, it's not the equation of the line, it's just the slope. It's just what m equals. Well, what do I need to do to find the slope? I need to take the derivative. How do you take the derivative of this? The derivative of x squared is 2x. What's the derivative of 4y squared? 8y, and then include y prime. And the derivative of 25 is 0. How would you get y prime by itself? What would you do? Subtract what? 2x, and then what would you do? So subtract 2x and then divide by 8y. It might be easier to simplify because we're going to use it. So 2 goes into 8 4 times. This describes the slope at any point. We're used to only using the x value, right? But in this equation, I need x and I need y to find the slope. So what's my x and y? X is what number? 3. What's y? 2. I need both. So what's the slope of the tangent line? Negative 3 over 8. What's the slope of the tangent line, or the normal line, which means perpendicular? Positive 8 over 3. So when we do things implicitly, you're going to have to use x and the y coordinate to know what you need to find. And these are no longer functions. You're now taking derivatives of relations like ellipses and circles and things like that. Number 3. If you're given this equation, find dy by dx, which is a fancy way to just say what? Y prime, right? They mean the same thing? Or take the derivative. So, how do I take the derivative, and then I'm going to plug in 1 and 2? One step at a time. What's the derivative of x cubed? I don't need a hook for it, only for y. This is where you have to be careful. Negative 2xy you have to treat like the product rule. What do I mean by that? One term is negative 2x, and the second term is just y. Can you see it's negative 2x times y? I haven't lost you yet, right? What is the product rule? What is the product rule? The first. What did I tell you the first was? Negative 2x times the derivative of the second. And the derivative of y is just y prime plus the first, the second, which is y, times the derivative of negative 2x, which is negative 2. Done. What's the derivative of y cubed? Treat it like x, 3y squared, but now you have to include y prime. And what's the derivative of 5x? 5. How do I get y prime by itself? Do you recognize the terms that have y prime in them? I underlined it. I'm going to write those down again. Just the terms that have y prime. What doesn't have a y prime needs to be on the other side. What's the inverse of positive 3x squared? What's the, right here is negative 2y. What's the inverse of negative 2y? Plus 2y. Do you see if you multiply it, it'd be negative 2y? It's plus 2y. If you factor out a y prime, you have negative 2x plus 3y squared. So take a y prime out of each term, and then how would you get y prime by itself? Is to divide. And again, when you do it implicitly, x and y will both be in the solution.
What happened to the 5? Yeah.
What happened to the 5? The 5's right here. So subtract 3x squared, add 2y. You're right, there's a 5 here, right? So that's included in the numerator. There's the plus 5. Thank you. You guys are smarter than me. So there's the 5. Now, how do I find the derivative at this point? What do I plug in for x? And what do I plug in for y? So where there's an x, I'm going to plug in 1. Where there's a y, I'm going to plug in 2. And now there'll be no letters, only numbers. X is 1. Y is 2. So in the question, so this becomes negative 3 plus 4 plus 5. So that's 9 take away 3. 6 take away 2. Where? Oh, it's 3y squared. Oh, that's going to change that right there. So 6 is still on top. Thanks for being my Jiminy Cricket. Help me out. Negative 2. This is 4 times 3, which is 12. Take away 2, which is 10. And then 6 over 10 you could also write as 3 over 5. There is some work involved to derive implicitly. Do you see how we use all these different rules? And x and y are both in play, right? Not just x. Okay, number 4. Do you know what x squared plus y squared equals 3? Do you know what type of equation that is? It's a circle. So here we have to do it implicitly. I'm going to take a fresh piece of paper here underneath so I have room to answer this. So notice which derivative they're asking you to find. Not the first derivative, but the second. So how am I going to do this? So first I need to find the first derivative. So the first derivative, what's the derivative of x squared? 2x. What's the derivative of y squared? 2y, but I need a y prime, and the derivative of 3 is 0. How can y prime be by itself? subtract 2x and then divide by 2y, and this just simplifies to negative x over y. How would I take the second derivative of that? What rule would I have to do? So the first derivative is negative x divided by y. What rule do I use when I'm dividing? Quotient. What is the quotient rule? The bottom times the, which, be careful, is what? What's the derivative of negative x? Negative 1. Subtract the top, which is negative x, times the derivative of the bottom, which is, be careful, it's 1, but what do you have to include? Y prime. So 1 times y prime is y prime. And then it's the bottom squared. And the question was to make sure you put the final answer in terms of y. So no y prime. So what can I put in place instead of y prime? What does y prime equal? So we're going to do some basic algebra here. We're going to substitute in. So no y prime in your answer. So y times negative 1 is negative y. A negative times a negative, positive x. Y prime is negative x over y. And in the denominator is y squared. Do you want it to be it? No way. So if I multiply this together, pretend there's a 1 underneath the x, and multiply the tops and bottoms. So that's negative x squared over y, all over y squared. Put a 1 underneath the negative y. Get common denominator, so multiply top and bottom times y. So this becomes negative y squared over y. This becomes subtracting x squared over y, and that's all over y squared. When you divide fractions, you multiply times the reciprocal. So we have negative y squared minus x squared over y times the reciprocal, which is 1 over y squared. Multiply the tops and bottoms together, and you get negative y squared minus x squared all over y cubed.
Wait, Grinton, I don't get how you...
Oh, I'm not done.
What? You're not?
I'm going to factor out a negative from both the y squared and the x squared. Remember the question says in terms of y, right? No x's. So factor out a negative from both. Do you know what y squared plus x squared equals? It equals 3. Why do I know it equals 3? The equation at the beginning said y squared plus x squared equals 3. So y squared plus x squared, order doesn't matter how you add, is the same as 3. And there you go. You found the second derivative in terms of y only. For the love of algebra.
Imagine the third.
For the love... Oh, do you want to do the third derivative?
No.
So the third derivative... I rewrite the second derivative as negative 3y to the negative 3. So the third derivative would simply be, what's negative 3 times negative 3?
9.
to the negative 4, but then I need to include y prime. We just said that what y prime equals. And then if you want it in terms of y, just for the love of algebra, we would have to keep going, right? But we're done. Over and out. What was your question first?
Why did you bring y prime in the beginning?
Why did I what?
Because to take the derivative of y, you have to do y prime.
So at the very beginning, y primed equal what? Negative x over y. When I took the second derivative, there's a y prime in the answer, so I did a substitution. Because I know what y prime equals.
Why is there a y prime?
Because whenever you take the derivative of y, you need the y prime hook. So I did the quotient rule. The bottom times the derivative of the top, subtract the top times the derivative of the bottom.
Oh, okay.
And the derivative of the bottom is y prime.
Okay.
Any other questions?
Do that with every time with the water, right?
Yeah.